Gavin wouldn't have benefited from the visualization. Anyway, Dean and Gavin, basically we are starting our areas and volumes chapter. We're starting our area and volumes chapter, and to start our area and volumes chapter, we are starting off with accumulation as net change. I showed them a worksheet from last year that we worked on that I could give you guys all over again, but instead of doing that, I'm instead using some old notes, but also some new examples, but I also reminded them that areas and volumes were something that we did last year. Accumulation has to do with areas, but also the accumulator function, where we might start at a constant and go to a variable. Right now, this is from constant to constant, which is why they're there, but you could throw in an x up here, make those t's, have that be a final amount, x, and it could be always accumulating. But area will be, I think, section 8.2, volumes by discs and washers, I think will be 8.3. No, all the volumes will be 8.3. Discs and washers, and what's new this chapter, shells. Perpendicular pair of shell, keep remembering that. And then section 8.4 will be arc length. That's new too. All right, here we go. Section 8.1, let's do the old. Let's enjoy the review. Homework is due tomorrow. Let's go. I've labeled all kinds of stuff because you guys should know that net change shows up all over the AP in so many different ways, shapes, and forms. Sometimes they could be asking for, hey, what was the change? What was the overall change? What's the displacement? Could be total distance traveled, but you would need to throw like an absolute value in the appropriate spot depending on the problem. It could be inside the integral, it could be outside. But even though they might be asking for the displacement or for the typical FTC, which is antiderivative B minus antiderivative of A, there's some calculus teachers that hate the capital F notation. It is what it is. Some people use it, so we have to know what's going on. A much better variation has this final amount solved for, which is just adding and has the initial amount plus the change. Hey, where'd you start? Hey, what changed? Cool, that's where you ended. It's so logical. And yet, when you start getting it in problems, we can get so mixed up. And what's going inside the integral usually for us? Some sort of rate. Some sort of rate of change. Some sort of how fast something is changing, and we're trying to figure out what the actual quantity, what the actual amount is. And I'm saying usually because of more complicated concepts. Who was it that was in here the other day trying to visualize a foot second? Not feet per second. A foot times second. Yeah, that gets fine. Okay, anyway. If your feet are inside the integral and you're integrating feet, you go to feet times seconds as opposed to feet per second going to feet or feet per second squared going to feet per second. It's interesting. Average value of given amount, mind-boggling. Okay, so what would you guys think of doing for this example? Ready, set, summarize first. Don't tell me how to do it. Summarize it. If you were doing this in homework, would you write the whole paragraph? Oh, I hope not. Prove to me you can synthesize the information. You can read it through. You can condense it into the short, sweet version. You ever try sweet and condensed milk? Yes. Short, sweet version? Right there. But that's for milk. Now we gotta do it for milk. Good stuff. Vietnamese coffee. Sweet condensed milk is better. Just kidding, I don't know. But anyway. But my math professor in college at my Christian university did say math is better than drugs because he totally threw us for a loop one day. You've already shared that story. No. What? We should drink. So, all we talked about was sweet and condensed milk and how cool math is. All right, so what have you guys pulled out? Don't just read it to me. What have you pulled out? What's going on?
Chemical flow is at 180 plus 3t liters per minute on the amount that flows into the first 20 minutes.
Is anybody's brain thinking like what kind of chemical and whether or not it's eating away the storage tank? No, that was just me. Anyway, I just imagine green plumes and like people running away and screaming. Anyway, so chemical flows into a storage tank at a rate of, okay, so we have how fast? We have units. We have a certain time frame, which means it's only going for an hour, right? Yeah. Ooh, 60 minutes from now. And so what's our goal? 20 minutes. So how long is it flowing? When does it start flowing? 0. When does it end the flow? It doesn't end, but they say, okay, just check and see what's happened in the first 20 minutes. I guess you could just stand there and make sure it doesn't overflow, or you can kind of have an idea of how long it's going to take. Oh, interesting. But what do they want to know? What do you technically, as far as the integration, need to know about the situation before adding a change? And then what do we put inside an integral to go back to an amount? The rate if we have it, right? Now why am I just going to cross that out and say forget it? I've done the math, but what does it say about the chemical flow? It started flowing at 0, right? If it started flowing at 0, and if they're asking how much flowed, is there any initial for me to worry about? No. It was 0 to begin with. 0 had flown at 0. Flowed? Anyway. Something like that. Exactly. I think what we got? Would this be a long answer question? Probably not. But if it was, what would you do? Speak to the man. True? Maybe kids are still learning that. Just kidding. Just starting to learn that. You guys, some of you are still learning. Wait. I didn't do FTC. Don't I have to do antiderivative of B minus antiderivative of A? I plugged in the 20 and then the 0 would just be 0. Okay, so forget that. I'm good. Okay, so at its core, is it a super complicated idea? Actually, the answer to that is very much so a yes. But as far as you're using it to solve, sorry, I said at its core. So technically, yes, it's a very complicated fundamental theorem of calculus, and it actually ties in with Euler's, interestingly enough, Euler's method. However, for today, is us applying it very difficult? No. So solve. Ooh, is this something you should be able to do by hand? I don't see decimals. Just because, let's make it fun. Go. Are you guys able to do the U prime in your head? If you guys have this, I want you to be pondering, how could they have made it harder? This is actually a pretty straightforward problem. Very similar, besides the fact that if it was by hand, that you probably could have thrown people off if they had to integrate by hand. But how could they have made not the integral harder, not the function harder, but the actual scenario? The AP is usually not this straightforward. Besides the U prime, besides the U sub need, how could they have made the situation or the scenario more difficult? Figuring out how many coterminal angles are in there to get it back to like something I can deal with. So dividing by 2 pi. 20. That'd be 30, right? Divided by 2 pi. It'd be 30 over pi squared. Pi squared would be 9-ish. Should be 3-ish, a little bit more. Yeah. I'm not sure if I totally could do that in my head. Bummer. I didn't realize it was 60. It's 60, right? In minutes? Mm-hmm. All right. You would have had to use your calculator, you party poopers. I could think about the increasing, decreasing nature of cosine and whether or not it makes sense for it to be 720. You could think about increasing in concavity if it's getting faster. But I don't think they're actually asking you to go that much in depth in this one. It's probably a simple one. Yes, I did 12 times 60 minus 12 times 0. It was just 720, so I kind of just did each of them. Antiderivative b minus antiderivative of a. And then antiderivative b minus antiderivative a, pulling the 6 pi out because I was lazy and didn't want to write it twice. It's hard to sign because you only have 2 pi to 6.28 to be precise. So you could have had fun. You could have done like actual 60 divided by 3.14. Yeah, about 20, but a little bit less. You would have to think about, okay, 20 and how many pi's would that be, or how many 2 pi's would that be? And 17. How many 2 pi's would that be? Oh. Yeah, see what I mean? The 19-ish is signed. And 19-ish times 6 pi. Oh, would be 8-ish. That'd be 20-ish. Ooh, wait, so is it just 19 in general?
Sine of 19-ish.
Oh, got it.
Oh, point.
What do you guys get as your final answer though? 720 plus. Or just throw in the interval? B. Did anybody think of how the scenario could have been harder? Because technically this was just asking for the net change. So we didn't even really need to look at like the f of 60 equals the f of 0. Like they weren't really asking for the amount at. They were asking what happened over the interval, and this shows. Oh my goodness, what are they doing outside? It's a kid with a cast being pulled around. I don't even understand. Sorry, coming back to your notes though. Remember how I said sometimes they're just asking for the net change? Like this is the net change. If they're just asking what happened over this time interval, they're not caring about where it started or where it ended. They're just caring about what changed, literally. So for both of those problems, we could have technically just thrown it into the integral and not thought about this situation. Which is why I said it was, this one specifically was simpler. How could they have changed the scenario? They maybe come up with a situation where it would have been harder. Okay, but in this situation, how would they have an initial with people coming up to a counter? Okay, so maybe it wasn't the beginning, maybe it wasn't when the store opened, but maybe when the fresh bread came out 2 hours later. I'm making up names, right? Which means there could have been a line already, and then there could have been a worker that was late who came to the counter and started processing the line. You guys see it? The line's being added to and the line's being subtracted from, right? And then you have the fresh breads and everybody comes rushing at this new, faster rate, right? And then they could be asking, like, hey, this poor little worker, they won't call more people to help him until his line is bigger than, and then I would hold 2, but it'd be more fun. So, whatever, depends on the store and their quality of service. But coming back, and probably the paycheck that's involved. But coming back. Let's say another person won't come out unless they're 7. So like, hey, after half an hour of fresh bread, should they call out someone new? I'm making up stuff, but you guys know how they do that, right? They have the people buying bananas off a display before the person started restocking the bananas. Like they add random who knows what. So if they were asking how many people were in line after 30 minutes of the bread coming out, which was 2 late hours after the store opened and after the person started processing, who knows? But the long story short is, it wouldn't just be what happened from here to here, from the beginning to the end, from the beginning of the line to 60 minutes later. Instead, it would be like, hey, there's this situation going on for this amount of time, and then this situation, and you're in the second period of time, and maybe someone has come in to start changing things. And they're asking for what is the current status way down here. Not the change, but the current status. Anyway, all of that could have made life way more exciting. But guess what else? Oh, homework! What else could make it more exciting? The idea of density. Yep. Process the information. Density makes everything. Process the information. Yeah. Take time, read the situation, draw a picture for the situation. How on earth does an integral apply? You guys can work in groups, you don't have to work alone.
Actually, the funny thing is, like, Minnesota is only 40 years old.
Hey, shush, we have a problem.
Don't tell me that you're still hanging on to
Don't get caught up in the situation. Don't get triggered by the gophers. I'll get triggered.
Why are you leaving? What are we doing right now that's better than intelligence?
Why?
What?
It's
kind of a
square mile. Sorry, what kind of stretch is that? What's a stretch? I know a stretch.
Don't start forming the Twitter feed. Think about the math behind it.
3 miles long.
That is 10 miles long, 3 miles wide. Okay, initials.
I don't know. You know, I don't know what you do. Like,
Honesty, I appreciate it. It's hard.
So, initial and then final is 2,000.
I already know how
Well, 3 miles from
Okay, then Ryan, find it and see if you're right.
They wanted, so like they did go from like 0 to like, no, they wanted like from 3 to 5, 3 to 10.
No, I'm just warning you, like, if this was a simpler problem, it'd be a simple multiplication and you're done. The problem is calculus is necessary because there is a varying component. Does that make sense?
Yeah.
There's a varying component. It's not a constant
10
rate.
No, it's 10. Oh, 10 miles long, 10 miles wide. Okay. It's just
I have people starting to do this, so why aren't you writing it down? Process the information. It doesn't have to stay in your head. Well, that's okay. This is just the land.
Okay, you could have just said land. 10 miles area.
It goes 500.
There's the bus.
Yes, it says along the road.
We can do
You said 3 by 10. It's 10 by 10. It's essentially the same thing.
Whoa! I got to make an equation for density, which is always changing depending on how far away from the road you are. Why would it make sense? Why would it make sense that the density of the gophers would increase as you get farther from the road? They're not being hit by cars. Or they're not being scared by cars. The farther away you are, the more gophers there are, the more out in the boondocks you are, whatever you want to say.
Why is everyone saying that
Wait, didn't I just get to follow the problem? Yeah. I just did what it told me to. I said, okay, at 0 miles, you were at 500. After 3 miles, you were at 2,000, which means linearly, I can make an equation for density. I didn't even make it. Sorry, my road was crossing out the important information. Okay, so whatever. I have this equation for density. That's cool. Why did I make an equation for density? Because it was there. Okay, some people wouldn't do it because it was there. I did it because it was there. But what are they actually asking about? The miles down here were like my x, right? And here was my y, but my y was density. And guys, what units would density have? 500 what per square mile? Gophers. Are rates always how fast? Rates can also be how much. So in a car, is velocity feet per second, miles per hour? Yes. But in this situation, my rate is not how fast the cars are going or the gophers are getting hit or anything else. My rate is how many gophers live in a certain quantity. Wait, why am I making a big deal about calling density rate? If you're supposed to be finding gophers, what's going to go inside my Instagram? Not gophers. Unless I'm trying to find like an average of gophers, putting in gophers, and 1 over b minus a to b.
What's the rate?
The rate, or the gophers per mile, or my 500 plus 15 all over 3 times, oh, sorry, I called it n. I guess I could call it. Do you want to do x for miles? Whatever.
Yes.
X, d, x. Wait, so what are my bounds?
0 to 10.
Why 0 to 10? It's on that stretch from, hey, here's 0, here's, wait, but what about the 3? Why didn't we use that? We did. They said what's going on at 0 and what's going on at 3 miles. This is what formed my equation for my density. The 3 was already accounted for. So some of you that were like 30 times what would you multiply by? The density was always changing depending on what part you were along the way. And it's impossible for me to actually do the infinitely many pieces along the way from 0 to 3 along this stretch of 0 to 10. But an integral can say, oh, don't worry, I can slice this up into infinitely thin intervals and accumulate accordingly. Now pause and recalibrate. Is everything in line with itself? Because we've defined variables. Does everything make sense? Because in an integral, everything has to make sense. Is the rate inside the integral? Yes. Are we trying to find the net change? It's different with density. Remember, rate isn't always how fast. Total population is the net change of density. Oh, that's weird to wrap our minds around. But is the rate of density inside the total population net change expression? Yes. What is my variable again? What kind of miles? Because I have miles here and miles here. Where'd this come from? Where'd this come from? The words. 3. What did we name the bounds? But what are the x's? Why does the 0 to 10 not make sense?
Miles from the
What way was I drawing my sections or my sectionings? Wasn't I saying this far from the road, this far from the road, this far from the road, this far from the road? Yeah. Does 0 to 10 help me with that?
0 to 3.
Right? I was going 0. So how does the 10 play in? X is how far from the road. How far from the road is from 0, right up against the road, to 3 miles away from the road. So how do you do the 10? This integral expression only tells me how many gophers are in this one little baby line. So what do I need to do? Extend it throughout the 10 miles. Oh. Wait, Lainey, you ready? What happens? Oh, wait. Oh, no! I was going to play with units. Hold on, pause. Give me like 2 seconds. Ready? Yeah. This is gophers. Did anybody realize gophers per what?
Miles Square miles.
So if I was to put per mile squared, what would an integral do to an acceleration unit? Wouldn't this become gophers to miles? But I don't want gophers to miles. What do I want?
Oh.
Woo!
Wait.
Bye guys.
Wow.
Later, gators. Have fun tonight, and if you see a density, well, it's all right. There's a different way of thinking about rate and a different way of thinking about net change.
Not 57.
Bye guys.
Yeah, parking on a hill.
Los huevos.